Hey guys, we're going to do the first section of Chapter 3 today. Chapter 3 deals mostly with, well, it has a couple topics, but the first topic is transformations. That is a topic that hopefully you did last year somewhat. Deals with different types of transformations, are reflections and rotations and translations and dilations and so on. So I'm going to go pretty quick through this. It's a lot of vocabulary in this first section. You can stop the video and write stuff down as you need to and restart it. So here we go. This is Chapter 3, Section 1. That's what the 3.1 means, right? And there we go. So a transformation. What is a transformation? It is a function, actually, or sometimes called a mapping, and it results in the change for a point or a figure. It might change the position on a graph. It might change the size. It might change the shape, right? All these things can happen with different types of transformations. So here we go. A transformation is a function or rule. Today we're really going to work with the fact that it's a rule that maps. That is a verb. It maps each point of a figure onto its image. It may be described with what is called arrow notation. And I'll show you what arrow notation is in a minute. And there's another type of notation involved here called prime notation. Prime notation uses this little apostrophe here. That is sometimes used to identify something called image points, which I'm going to talk about here in a second. So I have this diagram here, and I'm going to move it up a little bit so my video is not in the way. We'll go there. All right, so in this diagram, where I have this triangle here, we'll call this the red triangle, and we are mapping it onto what we would call the blue triangle. All right. And it looks to me, you guys, like this thing is a reflection, like over that line. Looks like the triangle has been reflected, like that line is a mirror, and the red triangle is looking at itself in the mirror, and it sees the blue triangle in the mirror, because the mirror changes color, I guess. I don't know. All right, so the red triangle is known as triangle JKQ, and the blue triangle is known as triangle, and this is how you say this. You would read this, you would just read it J prime, K prime, Q prime. Every time you see one of those little apostrophes, you just read the word prime. So J prime, K prime, Q prime. Here is this arrow notation right here, right? And that arrow, here's how you read it. That arrow is read maps onto. So when you see that arrow, what you're actually doing is you're reading maps onto. Triangle JQK maps onto triangle J prime, K prime, Q prime. Now, in a transformation, the original figure, in our case, the original figure is the red one, is called the pre-image. Think if you take a photograph of somebody, when you take a picture of somebody, they are the pre-image, and the picture is the image. So the new figure, or once you move it, or once you do something to it, it is called the image. All right, so we got the pre-image and the image. Notice that when you list these letters, I made a little point here. When you list these letters, they come in the same corresponding order, which is obvious when you're using prime notation. J prime comes first, K prime comes second. But when you're not using prime notation, it's not quite as obvious, but it should always be true. Corresponding points need to be listed in the same order. All right, we'll get back to that later, I'm sure. All right, so here we go. The first one of these transformations that we're going to do is the reflection. That's the only one we're going to talk about today, is the reflection. It is a transformation that maps a point across a line of reflection such that it has these following properties. And notice the line of reflection is line M. All right, so here's the properties. First of all, we got A. A is a point that is on line M. It is on the line of reflection. And this is saying that when a point is on the line of reflection, then A prime, I should have a prime on it, the image of A, I'm wrong about that, the image of A is A itself. Basically, it's saying when it's on the line, it does not move. So you can see here that A and A prime are actually the same point when you're on the line of reflection. Think about touching a mirror, and when you touch a mirror, your reflection point is right there where your finger is. It doesn't move. And then we have a point that is not on the line, and we're calling that point B. What happens to a point that's not on the line of reflection? Well, it reflects across the line. And I have an example right here, B and B prime. And when it goes across the line M is the perpendicular bisector of B prime. Okay, I know that's a mouthful. Let me explain it. So this B prime is a line from B to B prime. It is represented by this dotted line on your paper. That is the line B prime. And what we're saying is that this line M in the middle is perpendicular to it. So what does it mean to be perpendicular? It means it makes a right angle with it, a 90-degree angle. And this line M, the line of reflection, bisects it. When it bisects it, it means this length and this length are the same. And the way you show that mathematically is with this little tick mark that is already drawn on your paper for you. A little tick mark means those two lengths are the same. Like if you had a square, all four sides would have a tick mark because all four sides of a square are the same length. These little tick marks show you that it's the same length. Basically, when a point B, is being reflected, the distance from B to the line is the same as the distance to the other side of the line to B prime. All right, I hope that's not too confusing for you to do on video. All right, I have one more thing which actually is important. It's this notation. Let's do it in green, maybe. All right, this notation for reflection. This is a rule right here. This is how you write a reflection rule. And I will tell you what all these things mean. The capital R, of course, means reflection. This little m down here, it's a subscript. It's kind of lower down and it's small. This is the line of reflection. You put that line of reflection below there, kind of next to the letter R, and it's a subscript. Then we have this big thing in parentheses here. That is your pre-image. That is the thing that you are reflecting over line M. And then finally, you have the image. All right, we're going to use that rule. We're going to write rules today, and we're going to want to know how to write them using this notation, right? Reflection, line of reflection, pre-image, and image. I'll get back to it in a second. All right, so here I have given you a couple examples where I have given you a rule. You have to perform the reflection. And here I've kind of given you notes how to do it. So the first thing you want to do is you want to find the line of reflection. Typically, the line of reflection will be a vertical line, like x equals 2, a horizontal line, like y equals -3. It could be one of the axes, the x-axis or the y-axis, or we only do one somewhat difficult line in Math 1, and it's this one, or the opposite of that one. I'll show you sometime. So this is a line. Think about this. It's the line y equals x. I wish I had written it that way in the first place. It's the line y equals x, which means the slope of this line is 1 because that x has a 1 in front of it, and the y-intercept is 0. This is a line that has a y-intercept of 0 and a slope of 1. I'm going to do an example of it in just a second. What you want to do first is find the line of reflection. Do that first and draw it. Then here is how you actually do the reflection of the shape. You count the number of units from the point you're reflecting to the line, then count the same number of units to the other side. It's really easy. Let's do an example. So in this first example, I am reflecting triangle FGH. I have it on the graph. This is my line of reflection, x equals 2. So I find the vertical line x equals 2, and it would be right here. This is the line x equals 2. So to reflect over that line, let's go blue. All right, I go to each corner, right? I reflect each vertex. That would be the corner of the shape. So maybe I start with H. And since H is on the line, then H prime is the same point. And then maybe I go to F and I count how many spots to the line. 1, 2, 3, 4. And so I count the same number to the other side. 1, 2, 3, 4. And there's where F prime would be. It's exactly the same distance on the other side of the line. And I do the same thing with G. I count how many spots to the line. 1, 2, 3. 1, 2, 3. There's G prime. So I then just reconnect the points. And so I'm going to reconnect them maybe in green. And there is my reflection. It looks like a bow tie. I think it's nice on your paper. I can't do this very well on the marker board, but if you lightly shade it in with your pencil, I think that's a nice thing to do. Shade in the image. We're done with that one. Let's go to the other one. And to do the other one, I'm going to go up a little bit. Here we go. All right, so on this one, my line of reflection is the line x equals y. So that is this line that goes through 0, 0, It goes up 1 over 1, up 1 over 1, up 1 over 1, and so on. It's just this perfectly diagonal line that goes through 0, 0. That is the line x equals y. So now when I take my vertices, which I'll put in blue, when I take my vertices, I need to count diagonally. Count diagonal to the line. So it would look like this. 1, 2. It is 2 spots to the line. So I need to go 2 spots to the other side. And here's where f prime would be. H is pretty easy. It's 1, 2, 3 spots to the line. 1, 2, 3 diagonal spots to the other side. G is a little tricky. It's 1, 2, 3, 4 and a half. It's 4 and a half. So I go a half, 1, 2, 3, 4, and there's G prime. And I'll shade it in. And there is my reflection triangle across that line. All right, you can now do a reflection. Next thing. So here I just want you to practice reflecting a point. So it says find the coordinates of each image, right? These would be the images. These would be the pre-images. So first let's write down those ordered pairs. U is at 1, negative 3. V is at 1, 1. P is at negative 1, 2. And Q is at 3, negative 2. Okay, you can try this on your own if you want, and then turn the video back on and see if you got it right. But I'm going to reflect across each line, and then I'm going to write down where I end up. So point U is going across x equals negative 3. X equals negative 3 is this line. So when I take U across that line, I would go 1, 2, 1, 2. This would be U prime. And U prime would be at negative 5, negative 3. I will do point B in red. Point B is going to cross the x-axis. So here, point V. And so I would go 1 spot down from V, 1 spot to the other side. There's V prime. It's at 1, negative 1. I will do point C in green. I'm going to cross the x-axis again. Okay, so it's the x-axis again. And this time point P is going 1, 2, 1, 2. Here would be P prime. That is the point 1, negative 2. Negative 1, negative 2. And last up, I will do this one in purple. I am going to cross the line x equals y. That is this diagonal line through the middle. And I'm doing point Q. It's 1, 2 and a half, 1, 2. Point Q ends up here. Q prime, that is negative 2, 3. Okay. I think I have completed that. Mercy. All right. Now we have to write the rule. All right. So now I'm going to show you a reflection, and you have to write the rule using the correct notation. Now, usually these are really easy. I did give you notes here. These are how to find or draw the line of reflection. If you can't just see it, which most of the time you can draw it following these rules. And then we're going to write the equation and make sure you use the correct notation where you have the capital R, you have the line of reflection, and you have the pre-image. All right, so we're going to do one here. So, if this is my pre-image, right? And then the green one is my image. Can you tell where the line of reflection is? Well, look at these 2 points right here. I'll put them in red. So you got a point here and a point here, A and A prime. The line of reflection is halfway between them. So the line of reflection is right here. Look at C and C prime. The line of reflection is halfway between them. So 1, 2, 3, 4, 1. That's halfway between. This is the line of reflection. What do we call that line? There are actually 2 names for it. You know what? I don't have the, do I have it on the next page? There it is. Oh my goodness. So let me draw the line of reflection again. All right, that line of reflection could either be called the y-axis, or if I wanted to use its equation, it would be x equals 0. I actually prefer x equals 0, but either one is okay. All right, so how do I write the rule? All right, I write the rule by using this notation. So I want a capital R for reflection. Down here, I'm going to put x equals 0. That's the line of reflection. Or you could have put the y-axis. Either of those would be fine. And then I'm going to put the triangle, the pre-image, triangle ABC. There is the rule to reflect triangle ABC across the y-axis. What about this next one? Letter B. Where is the line of reflection? Well, find 2 corresponding points like Q and Q prime and go halfway between them. Or R and R prime and go halfway between them. See how these are both halfway between? This is my line of reflection. What's the name of that line? Well, I hope you know it's a vertical line. Vertical lines are x equals something. And in this case, it's x equals 1. So what would my rule be? I got to move up a little bit. My rule would be capital R. Down here, I would put the line of reflection. I'm reflecting across x equals 1. And this time, my pre-image is Q, P, S, R. Let's see, P, I guess it doesn't matter as long as I go around the shape. Q, P, S, R. And I've written the rule. All right, I think this is kind of dumb, but it says use arrow notation to show how each vertex of ABC maps onto its image. They're just saying, do this. A maps onto A prime, B maps onto B prime, C maps onto C prime. That's what it means to use arrow notation to show how one thing maps onto another. All right. Oh my goodness, people, I'm so sorry about this, but I got one thing left, and then I'm going to show you a few homework problems to help you. So stick with me. I'm sorry. Let's see. So I got this cool guy, Kenji, and he is taking this flag, and he's taking it in his hand. See the picture of me? And he's spinning it. He's spinning the flag in his hand. I wish I had a flag to spin. And he wants to know, when this flag spins around, what shape does it make? Well, let's see. If you took this and spun it around, and you went really fast, it would look like what shape? Well, it would look like a cone. One of the things you're supposed to be able to do in this chapter is visualize shapes being transformed. This one, when you spin it around, it would transform into a cone. Part B, what would the flag need to look like so that a sphere is formed when you spin it? Do you guys know? Great question. Here's the flagpole. I think the flag, if it was going to be a sphere, it would have to be a half circle. And if I took this thing and I spun it around, that wasn't a very good arrow. If I spun it around, oh my goodness, oh well. I think it would look like a sphere or a ball, right? All right. Let me show you a couple homework problems and we can be done. That's it for the notes. All right, here's the homework. And I just want to go through a couple things with you. So number one, this is like, oops. All right, number one is like what we just did in the notes. This thing is a cylinder and it's asking you, what would the shape of the flag need to be that you spun around? All right, so if I had this flagpole, what shape would be at the flagpole up here? Some shape up here so that I got a cylinder when I spun it around. All right, this is straight out of chapter 2 that you're taking a test on whatever, next time you're in class. Can you take these and graph them using the slope and the y-intercept? I hope you can do that. This one's slightly tricky. They're telling you that AC, the distance between A and C, is 67 miles. And they want you to solve for X and then find the distance between A and B. So I think you could set up an equation that says, you know, these two amounts and 67 and make an equation that you could then solve for X. I hope you can do that. You know, this distance is the distance from A to B, and the second one here is the distance from B to C. I hope you got that. This is the main one I want to talk about right here. So we're going to make a scatter plot. I don't know if you made scatter plots last year or not. I know my Math 8 class did. I hope you did, but it got wacky at the end of the year, I know. So everybody's scatter plot's going to be slightly different, and your equation's going to be slightly different. This is what you should do. Here on the x-axis, trying to move this up so I can get to it. On the x-axis, we are going to list the number of tired behaviors. All right, that's my x value. My y value is my test score. So here, test score. I'm trying to write sideways. I'm doing okay. All right, and we're going to number these. I think the tired behaviors, I can start at 0 and go by ones, because I think the biggest one is like 7. For the test scores, I think I can start at 0 and go by tens. So that'd be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And all you're going to do now is plot all these ordered pairs. And maybe it'll look something like this when you plot them, whatever. You can plot the ordered pairs. I wanted to make sure you knew how to do this part. Let's see. Draw the, let me put this in blue. Draw the line of best fit. So that line of best fit is a line that goes through approximately the center of all your dots that you made. All right? And then we want to find the equation of that line. So to find the equation of that line, you are going to pick two ordered pairs, not ones from the table. So maybe I'll pick that point and that point. So my point is 290 and 830. And I'm going to use those 2 points to figure out the equation What was that? 830. I'm going to use those 2 points to figure out the equation for the line. That is something you guys know how to take 2 points and come up with the equation. You'll find the slope, right? You'll find the y-intercept, and then you'll put the equation here. Now, your equation is not going to use these 2 points. These 2 points are definitely, my line is not good for this table. But you get the idea, I hope. And then once you have the equation, you want to use your equation when there are 5, when x equals 5, basically. Figure out what somebody's test score would be if if the number of tired behaviors, that's x, was 5. All right, that's how you do that one. The rest of these, I think, are no problem. You know how to draw a slope triangle and get the equation. And then these are right out of the notes. Take each corner, go to the line, go to the other side, boom, 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 and you start drawing the shape, right? Boom, boom, do the reflection for those right out of the notes. This is right out of the notes. So that's the same as we did in the notes. Here you're going to write the rule, write the reflection rule. Make sure you use a capital R. That is right out of the notes. And then this is also right out of the notes. I think you're ready. I am so sorry it was kind of long. Good luck.